which you already know, and you also know that from the email that you received. But just as a reminder, we talk about sustainability and chemistry in Germany. This is our dear guest today. We have a lot of people, which is really great. And I, of course, will be introducing them separately in a moment. And who is behind today's webinar? I hope that you already know My German University because you are attending today's session. But if you don't know what are the options available on our page, is that in case you want to study in Germany partially or fully in English, you are welcome to use a database to filter for the programs. The benefit of the Study Finder is that you can combine multiple filters, not only the basics ones like a subject or the city, but also, I don't know, requirement about work experience or specific language scores that you already have and want to apply to for the programs that are accepting that, and so on. Now, another good part is that you can combine different filters, and the second of all, you can also sort programs later according to, let's say, application deadline, which is frequently, most liked filter, I would say. What else? We are happy to have more than 200 articles that are written by internationals, and we, in those articles, which are free of charge, of course, we are trying to share the most important details, even like in terms of visa articles. There are country-specific visa articles, which is like usually a very interesting topic for internationals, like the waiting times, etc., etc. And therefore, even today, if you ask, we will be asking general questions about studying in Germany. I most likely will be also sharing those articles with you because the information is summed up or also even provided in detail there. So you're welcome to check that out. And to stay connected and make this journey of your application to German University a bit more interactive, we have those webinars. Today we have a subject webinar, but we also have general webinars when we talk about broader topics, and you are welcome to join those ones as well in case you want to know more about UniAssist, where my colleague Marie, for example, she goes step by step on the UniAssist page and shows how to register, etc. I believe some of the programs today are also using UniAssist, and this could be relevant. And of course, we also have subject webinars when one of programs from German universities are being presented, and we appreciate a lot guest time for joining us. As we know, their schedules are always very packed, and we are very thankful that you are joining us. And of course, the team that creates My German University, we are from different countries, different backgrounds, and then we are happy to share our own experiences of studying and living in Germany with you. All right, now to the topic. If you have used the filter of subject here in our study finder to filter for programs in chemistry and sustainability, you probably saw that the results are 335-degree programs. The very first breakdown is into bachelor and master's, and further you can narrow down by English only option in case you want, but it's also possible to search for programs that do have German component in it. It could be some courses, or it could be even like part of the program German language. If you want to have an overview of how it feels studying the subject in Germany, then you are welcome to check out the subject page, which has an overview of rankings, tuition fees, application and admission, and language requirements, again related to the subject. And then you, of course, have the list of programs that is already filtered for you. We advise you to look for the study program profile and not be guided only by fees, rankings, or city names, because all programs are unique. You will hear it today as well, and they are worth your attention. And then, of course, you are the one who decides which program is more or less more suitable for you. Briefly about the university landscape in Germany. There are universities and universities of applied sciences. What we want to pay attention to is that usually universities offer programs that are more research or theory oriented, and universities of applied science usually have programs that are more application practice oriented. In case you have questions about that, we could elaborate on this topic in the Q&A. Another suggestion is to filter for programs by subject, not the program name, because not all programs are called like Master in Chemistry or Bachelor in Chemistry, etc. The wording can be different, therefore it's advisable to search by subject. And now this brings me to the first university, University Gießen, and Sustainable Chemistry Program, from where we have two guests. I'm switching the slides because I did not want to have one slide for both speakers. And then I give floor to Ms. Laura and Professor 𝘱𝘢𝘪𝘥𝘷𝘦𝘳𝘴𝘪𝘱. I stop the screen share and yeah.
Thank you very much for the kind introduction. I will try to share my screen. Just a second. Yes. You should now be able to see the presentation, and now we should be in presentation mode. So a very warm welcome from Justus Liebig University Gießen to all interested students today. I will briefly start by introducing our institution. So about JLU, as it's called in short, we are a comprehensive research university founded in the year of 1607 with a long-standing tradition, but also innovation, and we are unique because of our exceptionally broad range of subjects. We offer everything from natural sciences to law, economics, social sciences, but also life sciences. We have continued top ranking results in environmental sciences, veterinary medicine, but also agricultural sciences. And we are also the only university in Germany that is named after a chemist. Maybe you've already noticed that. We are the second largest university in the federal state of Hesse with about 26,000 students and currently 3,100 international students. And according to the latest rankings of Times Higher Education and QS, we are among the top 400 worldwide. We count with 11 faculties and 9 research centers at the moment. And if you have heard about the German Excellence Initiative, which is the most important funding project within Germany, we are currently funded with 2 clusters within this excellent initiative. And one of them is within chemistry for post-lithium storage together with the University of Ulm and the Karlsruhe Institute of Technology. Gießen itself is a rather small city close to Frankfurt, so it's very close to an international airport, and it's about 60 kilometers north of Frankfurt. We have 94,000 inhabitants, of which about almost half of them are students. So we are a university city, and you can also see that in the surroundings. It's very student-friendly and very open, and just a nice feeling to the city. So after introducing the university from a general point of view, I will later speak about how to apply to our program. But for now, I would like to hand the word to Professor 𝘗𝘢𝘪𝘥𝘷𝘦𝘳𝘴𝘪𝘈, who is here with me today, who has already been introduced by Nino from my German university, to introduce the program that you are interested in studying.
Thank you, Ms. Laura. It's a great pleasure also for me, because I'm a living professor, also involved in this program that we are presenting today. Yeah, and as you have already heard, our name giver, Justus Liebig of our university, was really a famous scientist. He's also a founder of modern chemistry. He invented revolutionary modern laboratories, which if you come to us, you can still visit as a museum. Also, he invented instrumentation. If you can switch one further, please. You see that, for example, the American Chemical Society introduced an apparatus of Liebig into their work. And he invented a lot of things being totally interdisciplinary, not just a chemist. For example, also regarding nurturing, which was a big achievement at the time of the 19th century when there was still starvation in Europe. Well, now, 200 years later, on the next slide, you see that we are having totally new buildings, of course. You see that we work in state-of-the-art laboratories, and also we have new lecture halls at our campus, which directly brings me to the Master in Sustainable Chemistry. And it's an international master. We have a curriculum that is fully in English. We have no tuition fees. And once you successfully pass, there are lots of international career prospects, which I will talk about a little bit in a couple of minutes, a little bit more. Also, we will help to build up scientific connections, networks also to industries. And well, on the next slide, you see that sustainability is today a worldwide demand. And here you see the 17 goals for sustainable development of the United Nations. And our study course is directly related to quite a couple of them. For example, regarding here number 6, clean water. Without chemical processes, only 3% of the water on our planet are really something like drinking water. This is directly combined, for example, to number 7, affordable and clean energy, impossible without energy storage and materials. And if we want further transformation, then we really require also a transformation in industries, infrastructure, and so on, directly related to sustainable chemistry. And so we could go on. So if we pass on, you see further points, all these fields. Next one, number 2, number 11, climate action, and also number 12, responsible consumption, production, and where actually our products end up in the end are all related to what we want to go through with you in our curriculum. And therefore, we now present the curriculum to you. It's a master that is based on 2 years of study. We have 1 year that is with 2 semesters lectures, as I said, all given in English. They start with something that is more about principles, then more specific lectures, and I will show some exemplaries directly afterwards. You can also elect modules, so go by your choice on further modules in the first year. Then, as a unique, really unique part of our study curriculum in the second year, we want to strongly focus on research modules. And you see here 2 research modules and 1 laboratory project, and all this is then crowned by a master thesis in a research group. So now let's go more into detail on the next slide, where I can show something like one of these rather basic and conceptual modules, which is on an introduction into the principles of sustainability. And here we will work on the 3 pillars of sustainability, where chemistry is, for example, involved into the one that is based on materials, but also we have more, of course, social relationship and also economies. So in this module, we want to teach you about the complexity and interdependencies of the concept of sustainability. Then to give you an example of something that is more specific, that is a module that is directly related to my person. So sustainable inorganic chemistry then takes up these terms and points like criticality, substitution, and recovery, and shows this on state-of-the-art and also for future materials. So to give you an impression, what happens actually if we want to have this future transformation and future technologies. This directly leads to the next example, which is a module on sustainable energy technologies. And this will lead you from energy harvesting to energy storage and conversion for, as I said, state-of-the-art and future technologies, starting with basics, for example, in thermodynamics, kinetics, and so on, and then leading to something. What comes next? Beyond lithium batteries, for example, future solar cells, and so on. So this is about the first year. Second year, as I said, is strongly related to research. Each of you can have 2 research modules where you can work in a situation which is based on a one-to-one supervision, for example, together with a PhD student. And then each of you will get a specific laboratory project just for you on a topic of sustainable chemistry. Then a master thesis where you can select the groups, which is on the next slide, because we can do this. So we are very strong in research on sustainability topics. For example, if you want to do novel materials, then you may want to enter the groups of Professors Marsley, Lepple, or my group. If your topic is more about catalysis, you can enter the group of Professor Schreiner. Or if you want to work together with a famous battery researcher, Professor Janek, you may want to enter his group. If you want to do recycling, it would again be my group. And here you see further names and groups, all which are available to you. And this now, after successfully passing, leads on to what happens after studying. And this leads to career prospects. And actually, our graduates will be able to work nationally, so to stay in Germany, or also globally in very different fields. For example, chemical research. Why not completing this with a PhD at JLU in one of the research groups, or in industries? Also, this leads to development evaluation. There's a lot going on the European level regarding regulation. Maybe you want to enter an NGO, work for authorities, or become a teacher and teach others about sustainability. Yeah, and with this, I want to hand back to Ms. Lauer. Well, here you see as a sum up, why study at JLU? I have shown to you, we have renowned experts regarding research. We combine this to specific lectures, and hopefully we all have a positive impact on environment and societies in the future. Ms. Lauer, please.
Thank you very much, Professor Müller-Buschbaum. So after having hopefully called your attention to this program, I would like to explain the prerequisites on how to apply. So the start of this program is always in the winter semester, which is always in October in Germany. And there are some specific prerequisites. You will need a bachelor's degree in chemistry or related studies, which has at least 180 ECTS credit points. And you will also have to prove English at level B2 through, for example, a TOEFL or IELTS certificate. But if you have studied something similar like environmental sciences or sustainability, you are also invited to apply because we will be assessing by a case-by-case basis. Yeah. So you also have the chance to complete relevant topics which should have been part of your bachelor's degree within the first 2 semesters of your master's at JLU. So this will be a small additional workload, but we are sure it's manageable. And we will later send the presentation and also provide you with a link for the full requirements if you have any questions, and you may also, of course, always contact us. Again, Nino already mentioned Uni Assist at the beginning. So I assume that most of you will have a non-German entrance qualification, so you don't have a qualification obtained in Germany, for example, your bachelor's degree, and then you will need to apply via Uni Assist. This will be possible via the program page. It is carefully described, and you will have to pay a one-time processing fee of 75 euros, and then your application, once it's completed, will be processed within 6 weeks. The application process for those people starts on the 1st of May next year and will end on 15th of June, so you will have 1.5 months time to prepare your application. If you have a qualification that you obtained in Germany, you will have a little bit less time actually, but the deadline on June 15th is always subject to possible extension. And then you will need to use the JLU application portal, which has the name 𝘗𝘢𝘪𝘴. Okay, so then up to the services for support and advice for international students. I work in the international office myself. We provide help with visa, financing your studies, scholarships, how to find accommodation, and what you can work during your studies. You are permitted to work as a student in Germany within a legal frame. And we also offer orientation week with many fun events and guidance. Also career preparation workshops for international students for extracurricular skills, peer mentoring, and also we have won an award by the Federal Foreign Office Prize for excellent support. So via the QR code, you will also be able to visit our homepage, but I'll also gladly provide you with the presentation later. And some other benefits of studying at JLU. We have a lot of offers for international students, such as free German courses during the semester. That's actually true. You can learn German here without paying. We also have an international student meeting center with a monthly program. You can rent bikes, which is also very sustainable, through an app on campus. You can use public transport for free, and you can also upgrade it to the Deutschland ticket and then travel within Germany. And you also have access to leisure opportunities, such as the theater and also the public swimming pool. So we are now almost coming to the end of the presentation. So if you would like to contact us and you have any questions, please feel free to use the chat in the Q&A session, or you may also contact the Institute of Organic Chemistry, Professor Wegner, who's not here today, but he is happy to answer your questions, or ask the International Office or also the Registrar's Office for questions on admission. Okay, so also some QR codes with further information. We have a brand new video on YouTube on the program with students. You can also visit the website, and you can also check out our Instagram, because we have an Instagram from the international office with authentic insights into international student life. So that would be it. I thank you very much for your attention, and we hope very much to welcome you in Gießen next year, and we look forward to welcoming you and receiving your applications.
Thank you very much to both of you for the presentation. I believe the interest is already there since I see the number of questions. And then this brings me to our next presentation about mastering chemistry from the University of Göttingen. Again, we have two guests, Ingo May and Isabel 𝘗𝘢𝘳𝘵. I believe I pronounced.
It's a little complicated. I'm sorry.
All good. And yeah, the program details will be provided by them, and I believe this program will be also liked by you. Thank you.
Yeah, let me share my screen shortly. And if everything goes well,
Yes.
You should see my presentation now. Thanks for the kind introduction, Nino. It's always a pleasure being here and presenting to interested students. And we are here for the master programs in chemistry. It's not specifically for sustainability at that point, but I want to convince you that we have quite some possibilities within our master's program, so you can shape your studies to sustainability if you want. So Göttingen is quite a nice place in Germany. We are not far away from Gießen, to be honest. It's not that far away, quite in the middle of Germany. So you can reach basically every position in Germany quite easily. Roughly said, everything is within 4 hours driving time. And the campus in Göttingen is, I would like to say, something a bit special. At least it's not at all universities like it's here, because the STEM sciences, they are focused at one position. It's called the Nord Campus. So we have the faculty of chemistry here. Directly related to us is the faculty of physics, geography, mineralogy is here. We have biology near. We have 2 MPIs in our near distance, and also the MPI for Sonnensystemforschung, so for solar systems research, is here. So you see, we are right next to each other in terms of research. That's quite fundamental, because that's the point that we still have an excellence cluster running, the multi-scale bioimaging cluster, which is basically a cooperation of all STEM sciences and medicine inside the Nord Campus, and gives us quite a living research landscape, which also goes directly to the possibilities you have as a student at the University of Göttingen. We are not as old as the university in Gießen, but we are also quite traditionally. So we were founded 1783. And we started with buildings within the city. Now we are located in the North Campus since 1972, which means we have quite old buildings, and this is not staying this way at the moment. Our laboratories are getting refreshed. So our first building is finished and is now since 1.5 years in use. That's the laboratories for students, and the research laboratories are just now on their way to being totally refreshed. We are organized basically in these 3 institutes, like it is always done in Germany, and I think in most positions where chemistry is taught, which means we have an institute for inorganic chemistry, for organic chemistry, and physical chemistry. And in organic chemistry, we also have biomolecular chemistry as a bit of a special topic. So the science between biology, physics, and chemistry done by 2 professors is here quite prominent. Our main research areas from our professors are functional biomolecular chemistry, sustainable chemistry, and analytical methods for molecular interaction. So these are the areas where you can do research work in, and I want to show you how you can go to research workers, or how our course of study is done. I think Ms. Lauer and Professor Müller-Buschbaum said most about how studies is really done in Germany. So we have a credit system. 30 credits is a full load semester, and our masters is also 2 years, 4 semesters planned. Quite importantly for us, we have no starting semester. You can start in winter and summer semester without any disadvantages in our due to our study program, and we have part-time options available, which means if you're coming to Germany, but you still have obligations from somewhere else, like kids, or you need to take care of someone, you can reduce your credits you have to do to 20, 15, or 10 credits per semester, and the standard period of study is automatically extended. So you don't have so much problem with staying in Germany, and all the legal things are easier to cope with if you know I won't be able to do the studies within the 4 semesters. The only semester which needs to do full-time, there is no other way to do it, is the master thesis semester, which takes us a whole semester in our case. This is 1 semester you need to study in full-time. Our program is bilingual, which means it can be completed in 1 language only, and our courses switch language every year. So if it's taught in English, 1 year later, it will be taught in German. And that doesn't mean you need to wait, because our program is quite elective. We have a really large elective area. So we have, to be honest, no thing written down you need to do. At every point you can choose. So that's an advantage and disadvantage, because it means you need to make your own timetable. If you come here, you typically come to the dean's office, and we have a talk about what you want to study, what's the direction you want to study, and then we make your first timetable for the first semester you are here. And from that on, you will every semester select courses you are interested in, to shape your field of studies, to make you the chemist you want to be. We have 3 areas: the professional studies, the professionalization area, 12 credits, and the master thesis, 30 credits. In total, 30 credits need to be elected from some courses, which means there's methods courses where you need to choose between diffraction method or spectroscopy and magnetism. You need only to do 1 of these, and the part A methods will be fully done. For special inorganic chemistry, there are 2 lectures among 5 you need to choose, 6 you need to choose from. And it doesn't matter which combination you choose. If you have done 2, you will be done with this area. And as you can see, this is also valid for special organic chemistry, special physical chemistry. You only need to do 1 lecture, and you would have fulfilled this necessity. And after you finish area E, applied chemistry, the remaining credits are within what we call thematic deepening. There's a total of 48 credits, 48 credits, which you can choose quite freely. You can do them in research internships, which basically means you can do up to 6 internships if you want per institute. You can do 2, and if you even want to do more, you could do 1 external research internship and 1 industrial internship. But if you wanted to be a real lab scientist, but if you're more into theoretical chemistry or physics, then you're free to choose within all STEM faculties we have in Göttingen. And as I showed you in the beginning, we are very near to each other, which means there's a strong cooperation between all the institutes, between all the faculties. And that means you can really choose to take courses from the physics, from the geology, geography. You can do courses from mathematics or from biology. The only border is it needs to be courses on master level, and typically you just come to the dean's office and we have a short talk about it, and we find solutions how you can do the studies you want to do. it's even better if you realize that we allow up to 60 credits within our studies to be from external sources. So that means if you like Göttingen as a place to study, but you're saying, okay, in Schweden, at Stockholm in Sweden, there are some courses I want to hear, then we strongly encourage you to take a semester abroad somewhere you want to study. And since we have the very free thematic deepening area, you can allocate these courses there, and it will be no problem to take them into account for your master's degree in Göttingen. You can also, if you want, you could also do your master thesis externally if you want. In the professionalization area, there's total of 12 credits, which is 6 credits in German. It's called so-called Schlüsselkompetenzen, key competencies, which are basically a language you want to learn. And of course, we have language courses you can take part in, or other courses, even freer. It doesn't need to be STEM sciences. There is courses like soft skill courses for how to lead groups, and even other faculties. Here you can really take the whole module handbook from the University of Göttingen. And since we're a full university like Gießen, there we have quite broad field of subjects taught here, and put these credits into account for your master's in chemistry at the University of Göttingen. So that all goes in the end to the master thesis, which means like 30 credits, 1 full semester. You will work in a research group of your choice. We have 19 professors here providing a lot of research topics, and in your studies, during your lab courses you choose, you will get to know the professors. Since we are no real large faculty, 19 professors is not that much. And we have like 600 students. There's quite some personal relation between our students, our professors, and the dean's office. And typically our students then find a task, a master thesis topic they are really interested in. And also, like Professor 𝘱𝘓𝘪𝘡𝘕 said, most of our students also then decide a PhD would be cool, 4 years again of research. And we are happy if you join our ranks in terms of a PhD student here. As you can imagine, and as I already told, international exchanges are quite easy to do since we have this thematic deepening, which really allows to take into account every courses you take at other universities. And of course, we have a lot of programs going on, Erasmus, BROMOS, Global Exchange Program. So from within the European Union, but also America, Australia, Japan, we have a lot of universities we cooperate with, and we have an exchange of students with these universities. And if you want to study abroad 1 or 2 semesters, since you're allowed to do fully 60 credits externally, just jump by the office and we can make a plan how to apply and how to make it real. I hope these caught your interest in how our studies is designed. If you have any questions, because it's a lot of information going on here, don't always feel free to write just an email or call us at the Dean's office. We are here for you, and we will support you in every manner, starting from how to apply and how to move to Göttingen and how to check your studies. Nino, handing back to you.
Thank you very much. I will just briefly write the email. Yeah, thank you very much, Ingo, for the presentation, and Isabel for taking the questions. Today, I believe my part will be easier because many questions are being answered already in Q&A. And I want to, it's the first time I have this kind of question about the certificate, so I want to make sure that yeah, everybody is on the same page. This is information webinar. In case you are applying or interested in studying chemistry sustainability in Germany, you are welcome to hear. You have already heard 2 program presentations, and there is no certificate for attending this webinar. If you need to somehow prove that you were here, you can use the confirmation emails that we sent you that you have been successfully registered, or take a screenshot of this right now and then show it to someone who needs to see it. All right. For today, last but not least, we have Professor Dr. David Raffaia, who will be talking about another master in advanced materials analysis from 𝘗𝘀𝘪𝘳𝘵𝘁 Freiburg. And as for all programs, some program Snapchat and of course the location is on the chat. But you already noticed that the presenters have better representation of their programs. Therefore, I stop the screen share and hand it over to Professor.
So good afternoon to everybody. I hope that you can see my slides properly. Yeah, nice. So I would like to introduce or to give you some information about the master degree program in advanced materials analysis. So first, like my colleague before, I would like to introduce Freiburg a little bit. Please don't confuse it with Freiburg. So we are located in the very eastern part of Germany. Freiburg would be located on the other side of Germany in Baden-Württemberg. So the city of Freiburg is quite small. I think maybe the smallest of the cities what you learn today. We have something like 42,000 inhabitants. The next airports and cities would be, or just to, let's say, assign the location of Freiburg. We are in south of Berlin, approximately 200 kilometers. Next airports to Freiburg would be Dresden, which are approximately 40 kilometers. Then Leipzig would be located like there. Prague is here, and then finally Berlin. We are a pure technical university, so it means we have no branches like, let's say, philosophy or social sciences and so on. What the profile is, you will see here below. So we have approximately 4,000 students. We are one of the smallest universities in Germany. I think there is only one which is more than me. It will be closed down. In the middle of Germany, our profile is material science, nanotechnology, chemistry, physics, biomaterials. Then other stuff from the techniques like materials engineering, technology, mechanical engineering. What is quite important for Freiburg as well is geoscience and geoengineering, because we are located in the mountains. And formerly we, let's say, operated some mines here. And this is not on the slides, but if I'm speaking about mining and mines, we are now using the old mine for material science and mainly, let's say, for the shockwave synthesis. In the mines, we are able, let's say, to use explosive and produce pressures up to 100 gigapascal, which is quite unique in Germany. Well, what now the main topic of the study course, Advanced Materials Engineering Analysis are. So we are, let's say, somewhere at the boundary between material science, physics and chemistry, but still material science and physics dominates. So let me start, let's say, with the duration. It's the same like for all English master programs. There are 4 semesters, in total 120 credits. And the, let's say, absolvents get the title of Master of Science. We have no numeric clauses, no tuition fees. There is only administration fee, possibly like on the other universities. It should be the current rate, which is just below 100 euro. So we start our program only in winter term, means yearly in October. And this week is exactly the starting week or the first week where we're starting to teach our students. So the institutes who are participating in the teaching in this master program is material science. That's the institute where I am heading. Then all physical institutes, or the majority of the physical institutes, which is theoretical physics, experimental physics, applied physics, and so on. Then the institute, which is called now nanoscaled and bio-based materials. And what is also, because we are speaking about advanced analysis of materials, we have a very good cooperation with 2 institutions which are located in Hamburg in Germany. That's DISI, which is the synchrotron facility, and 𝘱𝘀, which is the European free laser facility. And our colleagues who are working, let's say, in Hamburg on these facilities are giving typically online or on-site lectures in Hamburg. And there are also some excursions to this research center, which is very well designed for the analysis of the structure of metals. So the main topics of our study course is to submit, let's say, to the student or to show the scientific background and the experimental techniques which are used for the analysis of the atomic structure and microstructure of functional materials. And now we are combining, let's say, the techniques which are based on microscopy, diffraction, X-ray diffraction, electron diffraction, and so neutron diffraction even, and on the spectroscopy techniques. And this combination is exactly needed in order to understand the relationship between the production technology, the structure of matter, and the materials properties. So it means at the end of the days, we are teaching our students not only the analytics, but also how, let's say, to modify the structure and microstructure of metals in order to obtain better materials or wanted materials properties. When we are speaking about materials, then we mean historically also materials for electronics and optoelectronics, battery materials, thin film, hard coating, shape memory alloys, titanium alloys. That's something which is coming, let's say, from the physical metallurgy and so on. And nowadays we, let's say, renamed and modify one existing institute. That's exactly the Institute of Nanoscale and Bio-based Materials. So it means that our students get also the insight into the bio-inspired materials. So like my colleagues before, I would also like to say something about the requirements for admission. So we are teaching master course. So it means the, say, new students should have bachelor degree, which means at least 6 semesters or some equivalent. And the, let's say, preferred fields of study before in bachelor course is material science, physics, preferentially solid state physics, and also solid state chemistry. Regarding the English language skills, we expect, let's say, at least 90 points for TOEFL. For us or in Freiburg, it's internet-based test, so it means if you have the confirmation, it's okay. The other one would be IELTS with the score of at least 6.5, or of course the English as native language. The applications are possible only for the winter term because we are starting in winter, and the window for the application is between January 10 and April 15. Here you see the link to the webpage. So now to show something from the curriculum, then I would like to post or to show this table. You will also see that at the bottom that we have a lot of elective courses that exactly the same what the colleagues from the other universities told about, and optional courses. For both of them, the students are really free, and they can select each course from the offer of the university or, let's say, from the cooperating institutions. And here you see what, in fact, the main focus of our studies. So we are starting with crystallography, with the fundamental of crystallography, with introduction to atomic and solid state physics. Some of the modules are running over 2 semesters. Here you see the number of the credits. Immediately in the first and in the second term, we offer the functional nanomaterials and quantum theory. So what you see above there, let's say, obligatory modules, which are obligatory for all the students, and then there is a choice for the other courses. So, and then we go a little bit more deep into the structure and microstructure of materials. So we are offering the courses for structure and microstructure analysis, containing lectures about X-ray diffraction, electron microscopy, transmission electron microscopy, up to the high resolution, and also, let's say, the electron spectroscopy. This is exactly the lecture which is offered by the colleagues from Hamburg, Matthias Research with 3 electron X-ray lasers, and Basic of Coating Technology, which is, let's say, a lecture on Matthias' side. So in the third term, there is some continuation of the lecture about structural microstructure analysis. Here we are speaking mainly about, let's say, perfect or defect-free crystals. In the second part, we are speaking mainly about defects, crystal structure defects, which can help us to modify and to improve the material properties. Then there is a lecture on the laser physics, and spectroscopy, which is quite a large module. The fourth semester is fully devoted to the master thesis, and maybe you've seen, so I've seen it in the chat before, then many students ask already how it is, let's say, with the involvement in some research or scientific work and research projects. So this is exactly something which is obligatory on our plan. We call it research project, and the students can choose either the second semester or the semester for this kind of the work. So what are the job opportunities of our students after finishing this study? So the majority of our students is going to the research and development because so you may see it on the first slide. The distance between Freiberg and Dresden, which is the capital of Saxony, is approximately 35-40 kilometers or something like that. And already in Dresden and also in Freiberg, there are many, let's say, research institutes located like Fraunhofer, Leibniz Institute, and so on. And we are cooperating with those people, and they are looking, let's say, for PhD students and then also for the employees. So the other branch of the job opportunities is in the quality control, because it's always connected, let's say, with the advanced materials analysis or with advanced analysis of materials, and of course all branches which are working with the materials analysis. And here you see, let's say, the institution. So the research institute dominates semiconductor industry, which is quite strong in Saxony as well, and the people are now looking, let's say, for employees, for new employees. The ceramic industry, steel industry, composite materials, and manufacturers. So they are, let's say, the branches who are looking for students finishing exactly the study course in Freiberg, or study courses in Freiberg. So this is my last slide, just showing the contact persons. So I am the Dean of Study. I'm responsible, let's say, for the students of advanced materials analysis, and the academic advisor, so the person who is, let's say, taking care for the formal stuff and things, is Dr. Enker. You can contact us. I am not sure if I said that this course is the English one, so it means we don't expect, let's say, any German knowledge. Of course, our students are learning German because for daily life, and because they are also looking on the next employment somewhere in Saxony or in Germany, and for these reasons it's advantage to be able to speak in German as well, but it is not necessary for this course. So thank you for your attention. If you have some questions, then ask them, please.
Thank you, Professor Raffaia, for the presentation, the details. Thank you, Thorsten, for taking care of questions. Today, my main task will be to reading out the questions that were mostly already answered. And I believe some of them will be still interesting because people can see them as private answers. Therefore, I suggest like 2 questions per program, but dear guests, if you want to specifically mention anything or I missed or did not correctly select the question, feel free to just jump in and answering an additional question. All right, then I would like to start with Gießen as a first university that was presented, or the first program. And let's take one more or less technical question, another program content related. For technical question, Catherine already answered it. There was a confusion. Can anyone from the world applying, internationals also from outside EU, apply in their fourth semester without final degree? Sometimes it's problematic for uni-assist or so.
No, I wouldn't know that it's problematic if the people are in the final phase of their studies, let's say in their last semester. They can always hand in their transcript of records, and then they will have to hand in the documentation for their finalized degree once available.
Mm-hmm. Thank you. Yeah, dear attendees, I would also agree here that usually it's always possible. It's frequently the case for bachelors that you cannot apply for a bachelor's program without your final high school certificate or diploma, however it's called. But for masters, it's different, so you can freely apply. Now, a bit question about the content, which was the first one that came even before the presentation started, was about the so how early in the program can students begin participating in research projects, and what are the preconditions and available spots, if there are any limitations? Professor, you answered it in Q&A. Maybe I could also add on, is it possible to continue with master thesis as part of one of this project or research teams?
Yeah, that's so for Freiburg in any case. And we are, sorry, it was for two.
Thanks if you are answering my question. But well, you can also answer, of course, for your university. Yeah, so it is exactly intended like this. So both the research modules and the laboratory project are more or less to bring people into research and to get accustomed to what is actually done in the research groups. And this can then be also the base for a master thesis in one of the groups.
Mm-hmm. Great, thank you so much. One general answer from my side will be about VPD. There was a question if programs use VPD for uni-assist. No, none of the programs is using VPD as far as it lists on the pages. And Catherine already additionally provided email or information where to double check it, but I also had a look and they are not using VPD. For Ingo, there are questions for Göttingen, which Isabel already also kindly answered, but I would like to mention it once again. Ingo, you mentioned how flexible the program is, and there are some electives. Is there a common thing that students come to you and ask for guidance if they don't know how to organize electives for specific career paths?
So that's one of the great things being a smaller faculty, is that we can give individual guidance. And this is not also given by our deans of study and me, also the students between each other. We have a strong connection between what's called in Germany the Fachschaft. So that's students which are strongly involved in shaping the university and shaping our faculty. And they know very well that some older students studied it this way, and that's a good combination. So you've always find discussion partners when you want to shape your studies. And of course, Isabel and me, we are always there. That's my main job, is discussing with students how they do their studies. That makes such a very, very flexible program, which is only elective at that point, with only a minor part where you have a restricted choices capable for our students. So don't feel overcoped when you see this the freedom we give you. See it as a chance, and if you need guidance, we are here and we are happy to help you.
Mm-hmm. Thank you very much.
And perhaps I might add one thing. In the near future, Isabel, correct me, but in the near future, we will publish tracks, which is a special selection of courses for routes you can take in the master's program, which is then more guided, but that's not necessary to study this way.
So we have them already, of course, but we are just preparing some marketing materials. So it's looking a little nicer than it does at the moment. But if anyone is interested, we can give the information already by now. This is just guidance, a possible option we have. So it's not doing anything to the flexibility you have. That stays the same. It's just to help you with some examples we can recommend, so to say. One of them is, of course, sustainability.
Mm-hmm. Thank you to both of you. There was a question again to Ingo and Isabel about the special role in pharmaceutical industry, particularly in areas like sustainable synthesis, drug formulation, and chemical analysis. Can one shape his or her curriculum to then reach this career path?
It's a very specific question on which way to go, but I would answer it in a way that you have the chances of doing these research projects, which in a group, which are like 6 weeks of doing research at a specific topic. And if you're interested in this, I would tell you, ask Professor Ackermann. He has a quite large group. He won a Leibniz Prize, and he's quite into exactly these research questions. And if you have, I would enlarge it in a way that if you have any specific idea what you want to do later on, we can tell you who would be a possible partner, a professor, where you could find research projects you will be interested in, or you take chances of going to another university where you know a professor is working on a topic you want to do and take it as an extra laboratory course. The answer is basically you can shape it as you want, and I can guide you on how to do it because we have this freedom again at that point. But for this specific question, I would say Professor Ackermann, Professor Steinem, who are strongly in the direction of pharmaceutical sciences and interaction with medicinal chemistry, would be best opportunities to get some information here hands-on in the lab.
Mm-hmm. Thank you very much. And Professor Raffaia, for you as well, there's one technical question that I want to once again, if you don't mind, mention about. You mentioned there is no NC, no numerus clausus, and there was a confusion what exactly it means. Thorsten did address that in Q&A, but if you could also mention, so what does it mean for your program? Or like usually, it's the same for everybody.
Do you mean the administration fee now?
No, the numerus clausus that you don't have it.
Yeah, so you mean for the selection?
Yeah,
of
exactly.
Yeah. So we have, I think it was answered in the chat already by one of my colleagues. So we are just looking on the previous courses of study, what the applicants, let's say, absolved. And also it means that if it is too far to solid state physics, to solid state chemistry, or to material science, then we don't accept the applicants. Yeah, because it would be, let's say, quite difficult to get the same level for the beginners in the courses like what we expect. Also, it means something like mechanical engineering or some kind of technology. So I see it now in the chat. Mechanical engineering is not a specialization of the students, which is, let's say, well done. So we don't avoid it completely, but the students must, let's say, be prepared for the eventuality that they need more background in the physics or in the chemistry, or something like crystallography, what the typical courses for material science, physics, or chemistry are teaching.
Mm-hmm. Thank you very much. Just small addition also, that because we also frequently see this question, is that the program has no limited amount of seats, as I understood, and if as soon as you meet the requirements and there is no minimum GPA, but of course it shouldn't be fail, you will be in the program. But of course you should meet the requirements that Professor mentioned, and also it was listed in the chat.
Yeah.
Thank
and
you.
Nowadays, maybe I can say something to the number of the students in the running winter semester, winter term, what started just now. We have something about slightly more than 50 students in the study course.
Mhm. Thank you very much. There was a content-related question that you broadly addressed in the when you talked about the curriculum, but maybe in a few words, could you wrap up what are the given the program's strong methodological focus in Freiberg, what are advanced analytical tools or techniques that I will learn?
Yeah, mainly, let's say there are techniques for analysis of the structure and microstructure of matter. This is something which is typical more, let's say, for material science and physics, maybe than for chemistry. And the three general techniques or these three streams are based on microscopy. So it means we are starting, of course, with optical microscopy, then we go to the scanning electron microscopy and to the transmission electron microscopy up to high resolution and up to, let's say, all techniques which can be used in analytical transmission electron microscope. So that's, let's say, microscopy. Now you see the transition to the diffraction techniques, because in TEM you can do also diffraction on several levels. So the diffraction technique which we are teaching are X-ray diffraction, electron diffraction. Now in cooperation with our colleagues in Hamburg, we have also the possibility to make something like practical courses even on the synchrotron diffraction. And the spectroscopy is something which is, let's say, regarding the X-ray spectroscopy, electron spectroscopy, yields, technique like that, infrared spectroscopy, Raman spectroscopy, so all possible spectroscopy techniques. And one part of them is also the work on XFEL, which is the free electron laser in Hamburg, which was, let's say, a facility that started mainly with spectroscopy, with spectroscopic investigations. And now the people, because let's say they are improving the coherence of the beam or of the laser shots, they are able to do something like diffraction as well on very short time scale. That's impressive. You have passes with the duration of some picoseconds, and now you see, let's say, changes in materials which are happening in some parts of second, in picoseconds, something like that. So that's let's say the main focus of our materials, of our techniques. And then I spoke about the materials. We are in fact very free. So therefore I spoke about solid state physics, solid state chemistry. The majority of the materials are really coming from the inorganic chemistry, or it's inorganic stuff. So we don't have a real, let's say, expertise about real biological materials. So this wouldn't be, let's say, the best way. I spoke about bio-inspired materials, but what we mean is inorganic as well. Also, it's something like that you grow on some mascots or on some natural objects, let's say inorganic materials. And what the people, what the colleagues are also studying and what they are working on is, let's say, the influence of high pressures on the structure of material, for instance. So they were growing, let's say, some nanomaterials in depth C. Or I spoke about it at the beginning, we have the shockwave laboratory, so we can go, let's say, to very high pressures of something like 90 or 100 gigapascal and look on how materials are behaving under this pressure, how you can modify the structure, microstructure, and the properties of materials under high pressure. And what I probably didn't mention explicitly, that's, let's say, the production of metastable materials. That we are going, let's say, beyond thermodynamics a little bit and try to stabilize metastable materials for a longer time. That's the most, let's say, important topics in Freiberg.
Great. Thank you so much for this detailed answer. Dear attendees, what kind of smart things you will study now in Germany next year?